concepts of modern warfare are projected upon a battlefield greatly expanded in depth, both in front and to the rear of the forward edge of the battle area. This approach is made possible and necessary by the development of rocket and missile artillery weapons. Mobility and flexibility, the basic characteristics of these weapons, are essential for furnishing the continuous fire support demanded by the greatly increased frontages and wide dispersion of units in modern battle. The 115-millimeter multiple rocket launcher M91 is designed to be transported by ground or air. 3 launchers are assigned to the Direct Support Artillery Battalion when authorized by the theater commander. The 45 rocket tube openings in the cluster, arranged in 5 tiers of 9 each, are stabilized by 2 jack groups and 2 trail assemblies, which are staked into the ground. The launcher is laid for both direction and elevation in the same manner as cannon artillery and fired electrically. The 318-millimeter rocket MGR-3 Alpha, called Little John, is a simple, reliable, lightweight, general support, surface-to-surface, solid propellant rocket system. Little John carries a 260-pound warhead, either conventional or nuclear. The warhead is mated to the rocket motor section, and the complete round receives detailed inspection and electrical checkout in the assembly area. To maintain an even propellant temperature, an insulating blanket is installed on the Little John as soon as it is removed from its shipping container. Fully assembled, the round is 14½ feet long and about a foot in diameter. With handling bars, its 780-pound weight can be moved manually into place on its aluminum alloy launcher. The entire unit can now be towed with full ground mobility and even manhandled for short distances, airlifted in parachute and air assault operations, or transported by helicopter to the prepared firing position. Emplacement here, preparatory to the firing sequence, takes about 10 minutes. The Little John launcher is stabilized by 2 jack assemblies and a rear support, providing a level base for firing. The insulating blanket is removed from the rocket just prior to firing. The launcher beam, which supports the rocket for firing, is elevated manually. Maximum elevation for the Little John is 978 mils. With traverse limits of 267 mils right or left of center, the weapon is aimed similarly to cannon artillery. Low-level surface winds, which will affect it during its acceleration phase, require measurement for speed and direction by the wind measuring set. These indications are transmitted in electrical signals to the fire control station, converted into miles per hour, and then mils for launcher deflection and elevation correction. About 12 to 15 minutes are required to emplace and fire the Little John. Accuracy is obtained through a spinning action applied to the rocket before firing by a spring-driven motor at the rear of the launcher. When the rocket reaches a rotational velocity of 3 revolutions per second, an igniter sets off the propellant. The range of Little John is 20,000 meters. The 762mm Honest John rocket, MGR-1 Bravo, is an improved version of the first operational field artillery rocket system. In the assembly area, the rocket, with its propellant protected against temperature changes by electric heating blankets, is assembled utilizing a wrecker or the traversing beam of the M405 handling unit. As soon as the rocket motor is positioned on the handling unit, a specialist begins its inspection and checkout. The Honest John warhead, either conventional or nuclear, is assembled to the rocket motor with 4 mating bolts. Assembled, the complete round measures 25 feet in length. It weighs approximately 2½ tons and is transferred to the launching beam of the self-propelled launcher by either the wrecker or the M405 handling unit. It is secured by steel shoes, which will guide it up the rail-type beam when it is fired. For travel, the launching beam is folded back. With the assembled rocket in place, the 17-ton M386 launcher has the mobility of medium artillery. Both rocket and launcher can be transported in cargo aircraft. Emplacing the weapon at the firing position takes the 13-man crew about 15 minutes. The launcher is stabilized with 3 screw-type jacks and can be cross-leveled to compensate for cant. The beam assembly is extended for firing at the firing position, locked and the blankets removed. The rocket fins are attached. Sighting and laying procedures, including bore sighting and the use of gunner's quadrant and panoramic telescope, are like those used with cannon artillery. Direction and velocity of low-level winds used in deflection and elevation calculations are measured by the trailer-drawn wind measuring set, which is equipped with a hydraulically elevated 50-foot mast. The launcher's hydraulic elevation raises the launching beam to a maximum 1,244 mils. And its manually operated rack and pinion mechanism traverse allows 266 mils right and left of center. The Honest John firing sequence takes about 10 minutes. Final firing data are applied at X-2 minutes. To reduce the effects of thrust malalignment, the Honest John is equipped with 4 spin rockets that cause it to rotate after it leaves the launcher rail. It is fired electrically with thermal batteries or vehicular power source from a remote control firing panel. In less than 4 seconds, the propellant is burned, delivering 110,000 pounds of thrust to launch the Honest John to a target as far off as 38 kilometers. 1 Honest John battalion is assigned to each infantry, mechanized infantry, and armored division. The Sargent Guided Missile System is an all-weather, all-terrain, nuclear-capable weapon with quick reaction time, rapid employment and displacement, rugged, reliable, simple in operation, and immune to known countermeasures. The backbone of the Sargent Guided Missile System is the 8.5-ton launching station, which carries all the equipment necessary to assemble, to program, to orient, erect, and to automatically fire the missile. 3 hydraulic jacks provide 3-point suspension for the launching station at the firing point, stabilizing the platform on which the missile is assembled and fired. When the launcher is leveled, the superstructure is raised hydraulically. The missile sections are brought to the launcher for assembly. Coordination of equipment and procedures enable the Sargent guided missile system to occupy its position in about 8 minutes. The rocket motor and guidance section are hung and locked to the underside of the launcher boom. The guidance section is the essential difference between shorter range pre-flight rockets and the Sargent system. The Sargent guidance section is mated to the rocket motor by 4 bolts. The warhead section, containing the nuclear warhead and arming and firing circuits, requires no pre-firing checkout by the crew, since all checks are performed automatically by the firing set at the forward end of the launching station. The firing set enclosure houses all the electronic components necessary for the launching. The firing set computer, which programs the missile for launching, processes the firing and target data while the missile sections are being assembled. The Sargent missile assembly is complete when the warhead is bolted to the guidance section and the missile's control surfaces are locked into place. It is now ready for the automatic countdown. The guidance platform is aligned with the firing azimuth by the azimuth orientation system. And as the small Sargent crew clears the area, the automatic countdown is now at X-10 minutes. At X-3 minutes, the firing set operator leaves his enclosure to monitor the final moments of the automatic countdown from the remote firing position. During the final seconds, the missile is automatically elevated 5 degrees, slews to the firing azimuth, and rises to its firing elevation of 75 degrees. The range of the Sargent is from 25 to 75 nautical miles. With these outstanding capabilities, the Sargent guided missile system is normally assigned to the Field Army with a mission of general support to a corps. The Pershing guided missile system is the United States Army's longest range field artillery weapon. Maximum tactical mobility is achieved by mounting the firing battery equipment on 4 vehicles. Lightweight, tracked or wheeled vehicles may be used. The Pershing system is air transportable and can be employed at environmental extremes of temperatures, in high winds, high humidity, low visibility, and darkness. The warhead vehicle carries the Pershing warhead section, the missile air fins, and other operational equipment to the firing position. The Erector launcher supports the missile during transit, provides a platform for mating it to the warhead section, and for test, checkout, and azimuth laying operations. It erects the missile and provides a level, stable platform for its firing. A third vehicle carries the power station and the programmer test station, which determines the missile's flight worthiness, computes the firing data, and inserts the guidance presets and energizes the missile for flight. The radio terminal set and placed away from the firing point is the core of the Pershing specially designed unique communication system, utilizing a tropospheric scatter radio highly immune to jamming and interception. Its long range and high reliability permits launching operations to take place up to 100 miles away from Pershing Battalion headquarters. The erector launcher is continually leveled and stabilized by automatically operated jacks. The warhead section is mated to the first and second stage rocket motors and the guidance and control section. The missile is designed to lift the warhead from the Earth's surface to a point in space and release it with sufficient velocity at the desired angle and direction to follow a true ballistic trajectory to the selected target. Before erection, the assembled missile is tested and checked out with equipment in the programmer test station. There, the guidance presets are worked out by the fire data computer. Before flight, the firing azimuth, velocity, and displacement are inserted into the missile's inertial guidance system. During the firing sequence, signals from the programmer test station control the functions of the erector launcher. When the missile is erect, the launcher rotates it to the firing azimuth. After a final monitoring phase, control of the missile for firing is transferred to the remote firing panel about 150 meters away. Following the initial thrust provided by ignition of the first stage rocket motor, the missile enters a coast period, preset into its guidance and control system, which varies with distance to the target. Following the coast period, the first stage is separated and the second stage ignited, accelerating the missile on its flight path. With termination of second stage thrust, the warhead is separated from the guidance and control section and spin stabilized to maintain its trajectory. Clean separation of the warhead is ensured by explosive rupture of the second stage motor. The warhead itself, specially coated against aerodynamic heating, re-enters the Earth's atmosphere. The Pershing's range is 400 miles, and it is normally employed in general support of a field army. Whether deployed for nuclear combat or close infantry support in the field, the ground-gaining forces can continue to rely on the techniques, the men, and the weapons of the field artillery.